I think we can get started. Okay, so this guided topic session, what we're going to talk about is Module 4, which is the strings module, just launched. We're going to talk a little bit about interview techniques and kind of, breaking down problems. I'm going to cover a little bit of Python tools for this week. We're going to cover just what are strings. We're going to cover a little bit about slicing. We're going to do a sequence comparison and talk about sequence comparisons, reversing sorting, and string splitting. All right, in this class, just after I do that, we're going to go over the minimum number of palindromic characters problem. I don't know if anyone has, hands up in the chat if anyone has actually tried the palindromic characters problem yet. All right, well, we'll go over the understand phase together. And then at the end, if you didn't do the last group practice, I'm gonna sort you into a room so that you can do the last group practice. And then if you have done the last group practice, we're gonna practice doing something called run length encoding, a really simple version of it, to just kind of practice a couple of things that may come up in interviews. So yeah, so that's what we're doing. Okay, let's get started. The first thing that I want to do is cover these tools. I'm in the minimum characters place right now, but what I'm just going to type here, and I'm going to actually make this a little bit bigger as I have been asked to do that. Can everyone see this? Is it pretty clear? Okay, cool. All right, so let's talk about strings for like 2 to 3 minutes. They're not a lot, I'm not going to go super deep because there are videos, and so, and I'm assuming that all of you have dealt with strings before. When I talk about strings, I'm talking about, some characters or some numbers. This could be anything. Right, so we can put anything inside of a string. We can also do a lot of different transformations on strings, and that's kind of the big thing that's going to come out in these is usually transforming strings. So one of the most important things to learn to do is string split. So if you think about most text data is like words, right, like this. And so splitting strings on a space is like one of the most common operations that you'll do with strings. So I'm just going to show you how to do that. Let's see, I kind of always want to basically, anytime I'm dealing with strings, there's so many string operations that you will deal with. And I've linked this particular cheat sheet in like the different modules and things, but always have a cheat sheet up anytime you're dealing with strings, anytime you're trying to solve a problem with strings, because not only are they different in each language, but having those there will help you kind of remember what capacities you have with strings. So I just recommend always keep a cheat sheet up. So yeah, and let's see, I'm actually looking at this because I always forget exactly how to split. Let's see, it's just s.split. So a string dot split, whatever you pass in here, this is going to be the delimiter, the thing that it breaks the string up into. And so now this is a list of words. So if you print this, a list of words, what you'll get is a bunch of different words. So you can kind of see this operation is really, really super common. Oftentimes, if you're reading something like a CSV, which you will do really, really commonly, you can do stuff like split on a comma. So you can kind of see that happening here. But you can really split on anything, right? Like if you look at this. So anytime you're trying to parse something like an email or whatever really that you're trying to parse, honestly, a lot of times what you're doing is just splitting strings. The CTO of NPM likes to joke that all web developers really do is split strings all day, and it's definitely true. It's really what we're doing at the base of things most of the time. So that's splitting strings. Now, I just wanted to look, okay. So slicing. Slicing in Python is it's easier to me in Python than it is in any other language. The reason being is because they've kind of integrated it into basically how you index. So if you recall the way that you index into like a list of words, if I want the 0th word, right? If I do this, what I'll get here is some characters. And then let's go back to, sorry, splitting on a space. There we go. So I'll get this first thing if I index like this. You know, if I go into the second word, right, I'll get or, so that's this index. But what I can do with splitting is I can actually go from like 0 to 2 by putting this colon here. It's a big deal. So there's like a split, it's the first 2 elements, but I don't have to do this just on a list. I can actually do this on a string as well. And what that'll do is it'll get me the first 2, you know, letters in this string. Something to remember is that a string is really just a sequence, right? It's very similar to a list. And so you can iterate over a string. You can iterate character by character, or you can, if you want to do something like process every single word, like in some of the stretch problems, there's that. What you'll want to do is split and then loop over the list, right, that you get. So that's like kind of the basics of slicing. But in Python, there's some stuff that you can do. It's pretty cool here. If you do this like this with a string, what you're doing is you're saying go from the beginning, that's the default argument here, to the end, that's the default argument here, and increment by -1. So that's go backwards. So if we look at this, it's the whole string reversed. So it's like a really simple way to reverse a string. I can also kind of be super weird and like really jumble it up. That's every letter backwards, but only, or sorry, every other letter and backwards. And then if I wanted to just do every other letter, for instance, I could do this, and that's forwards. So if that, you know, makes sense. There's all these different sort of operations that we can do here. And so a lot of these problems will actually require you to do something, deal with splitting and deal with like reversing things over a split. So that's kind of the main thing that I wanted to cover there. And then, yeah, that's the other thing I wanted to mention is that if you compare 2 strings, you are really actually looping over every element in the string sequence. And so that's like a linear operation across those 2 pieces of input. So don't treat string comparison as like a single operation. And when you're in an interview, interviewers are looking for that. String comparison is a expensive operation because it is like it's based on the length of the string. And a lot of times what you're doing with these problems is processing the length of 1 input string or 2 input strings. And so those comparisons can get very expensive. So if you're comparing in a loop, just be mindful of the fact that that is a loop itself, right? It's going over the whole input. All right, so that's pro tips I want you to keep in mind before we jump into the minimum palindromic characters. Does anyone have any questions before we jump in? Anything they want me to like go into or? Cool. If you come up with one, you want me to jump in, just drop it in the chat and I'm here. Okay, so I'm going to get rid of this stuff and we're going to talk about the actual problem. Okay, so hands up in the chat if you have attempted the is palindrome problem or if you've watched the video where I walk over it. Nobody? Nope. Okay, so no one's walked over it yet. Okay, so this problem is different than the palindrome problem the because of the way the test data is set up and because of the constraints. So let's go through the understand phase, and I'll kind of compare and contrast those two problems so that you can see in your mind like where the match differs and why we have to come up with a separate approach for how to figure out what a palindrome string is there versus here. So you're given a string. The only operation allowed is to insert characters in the beginning of the string. So my output is going to be something, but the method, if you've watched the Empire stuff, I talk about how sometimes it'll talk about the method that you must use or the method to find something. And so this is the method. This is where we only have one way that we're allowed to mutate the string. So we're given a string and we can only insert characters in the beginning of the string. What we have to find out is the number of characters that are needed to be inserted to make the string a palindrome. So in order to make ABC a palindrome, I would have to put B here, and then I'd have to put C on the other side of B, right? So the answer would be 2. Now, there's a couple of things in this problem that I note aren't in the other problem. So first, we're given a string, but we're not told anything about the string. Like maybe the string has punctuation, maybe the string has capital letters and lowercase letters. It doesn't say. None of the examples here have uppercase and lowercase letters mixed. They don't have punctuation, and it doesn't tell us to disregard punctuation like it does in the first problem. So paying attention to the difference between the inputs here is really key. In this one, it's the whole string must be a palindrome. It doesn't matter if maybe we've put some periods or some spaces in there, the whole thing has to be a palindrome. The other thing is, the method has us inserting characters at the beginning, not at the end. Not in the middle. We can't mutate things or rotate them. So, those transfer, we can't clean the string. We can't go through it and delete spaces or characters or anything. The only operation we're actually allowed to do to the string is to add characters to the beginning. It doesn't say what characters, it just says characters. But the data type of our input, it's a string. But what's the data type of our output? It's a number. It's the number of characters that are needed to be inserted. So we have to find this answer and then return the number of characters at the end of it. Now, in the isPalindrome function, we had to do something. We had to clean the input before we were able to consider whether or not it was a palindrome. Just turn that do not disturb. Supposed to turn on automatically. There we go. Anyway, yeah, anyway, so the difference between those two problems is in that you can't really change the input. And what you're returning is not a true or false. What you're returning is a number of like operations that you'll have to do to mutate the string to a certain point. So it's a very different problem. Okay, so that's kind of the understand phase. Let's start like thinking like a robot. I'm going to go step by step and just do this myself. I did it for a second ago like this. If I wanted to turn ABC into a palindrome, I basically have to consider A the center and then just put B here and then C there. Remember that a palindrome is a string that is the same backwards and forwards, right? This, again, doesn't say not to consider case. And so this is got to be a case-sensitive palindrome that has punctuation in the right spot. Okay, so now let's consider this second example. What I've got is AA, CEC, and then 4 A's. So if we think about like kind of what's the smallest subsequence in here that is already a palindrome? Well, it's about like this, right? And we know that, you know, the middle of this palindrome is not further than the middle of this, right? Sorry, of this whole string. So the operation that we're going to have to do is only to add things to the beginning now, right? And so in order to make this a palindrome, what I'd have to do is I'd have to take this A and put it, and put it at the end. And then I have to take this A and put it before that other A, you know, just in case it's like a, you know, not an A, right? So that's kind of like the operation that I have to do here in order to make this a palindrome. Okay, so if I were to write that out, how would I write that out? I'm just gonna create myself like the label min characters, and then I'm just gonna put pass here so that it doesn't have that X. I find that X very distracting. And then so what I'm gonna do next is I'm gonna write out kind of what's the series of operations. So let's see. What I need to do is take a look at the input string and check. I'm gonna check to see if the input is already a palindrome. That's kind of like the best case scenario. It's already a palindrome and I don't have to add anything, right? Now, the next step is if it's not, basically if you kind of think of like a palindrome, there's two ways to think about it. It's either the same backwards and forwards, or it's kind of the same if you like fold it in half, right? Or like compare two different sides. So that's sort of two different ways that I could look at that. Let's see. And I just wanted to get a couple more examples out here. I have those written down. So let's see. Let me think of like another example out here. So I want to check to see if the input's already a palindrome, and then if not, I want to take the letter from the end and try moving it to the beginning. So take, if not, or really while it isn't, I'm going to take the letter from the back and put it on the front. And then I'm going to, let's see, count up by 1, because what I'm really trying to do here is this output is, it's got to be a number. It's the number of characters here. So start a counter, that's what I need to do, and then increment the counter, right? So I'm just gonna kind of try this to see if it like, you know, starts to work with my examples. And then maybe I can kind of play with it and discover more. So now that I have kind of a basic plan, I'm gonna do my thing here where I put it here, right? And then, okay, so one of the problems though that I've run into is check to see if the input is already a palindrome. Well, I don't have a method right now of checking to see if it's a palindrome. I kind of talked about like different ways to check to see if something's a palindrome, either look at it backwards and forwards or, you know, kind of fold it in half. So what I need to do is I need to make a function, like another function. And I'm going to call it is palindrome, and then input string. And so what I want to do in this function is check to see if it's a palindrome. So we talked a little bit about sequences earlier, and what I really want to do is see if it's the same backwards and forwards. So because we don't have to clean anything. So I'm just going to return the input string, whether or not it's the same as the input string, but backwards. So that's the method I'm going to use to determine if it's a palindrome. I want to check to see if this is actually a palindrome, so I'm going to call this function. Let's see, what's this complaining about? Okay, I'm just going to put that pass statement. There we go. And then I'm going to print is palindrome, and I'm going to pass in a palindrome and not a palindrome. ABC is not a palindrome, and is palindrome, ABA is a palindrome. Okay, so this should return false, and this should return true. False, true. Okay, so that part of my solution works. Rather than trying to do this in, I mean, it's just one line, but rather than trying to do it in your solution, like as this line, that's going to get really difficult. And so what you want to do is give it a label. And that's really, like, it's going to help you kind of not get lost, right? And this has like a, you know, this is like a nice way to kind of remember things. Okay, so let's see. Let's see if the input is already a palindrome. So I haven't given this as the input string. And let's see, is palindrome. So I'm going to just see, is the input string a palindrome? And I'm also going to start a counter. So I'm going to say characters needed is 0. And then I'm going to return characters needed. All right, let's see. Sorry, so my neighbors are like having a party suddenly. Okay, characters needed 0, return characters needed. All right, so then I'm checking to see if the input's already a palindrome. So while it isn't, I kind of gave a hint here that said, like, I want to use a while loop here, right? While I haven't found a palindrome. So what I'm going to do is say, while input string isn't a palindrome, and let's see, while not is the way to do that. Okay, so now if my input string for this is, I'm going to just kind of check my base case, minimum characters. Let's see, input string is a palindrome. I'm going to give it ABBA. Then, cool. Let's see if minimum characters returns 0. Let's see, oh, inspected indented block. Oh, yeah. Let's say character needed plus equals 1. Only did this once. Okay, so it looks like that's working in terms of like my pipe. My pipe works. So my input string comes in. So far, characters needed is 0 because I've only ever given it an actual palindrome. And then if it's not a palindrome, all I'm really doing is like incrementing the counter. So now I need to take the letter from the back and put it on the front. All right, characters needed. No, what I need to do is change the input string. So I kind of need a spot to keep the string that I'm mutating. And so I'm going to give this, I'm going to give it a name, palindrome is the input string. And then I'm going to start changing palindrome because I can't really modify input string. I can only add characters to the beginning. And I don't really want to change this input string. I just kind of want to have like a, you know, another variable to like temporarily modify things. So what I'm going to do is palindrome equals palindrome, but I'm going to use slicing And I'm gonna go 0 to -1. And so let's go from the start of the string all the way till the last character, but stop right before. Okay, so basically, and then I want to put it on the front. So I want to do palindrome of 0, or sorry, no, of the back. So let's do -1, the last character. All right. Oh, plus. No, I'll use that. Okay, let's see if that works. And doesn't crash. All right, palindrome reference before assignment. Oh, palindrome equals input string. There we go. Sorry if that was confusing to watch. There we go. Okay, so this is still working, but now let's give it another one, another example. Let's give it that ABC example. All right, and let's just see kind of what happens there. Okay, so the problem that we get to here is we kind of run into this like infinite loop, right? If you can't remove characters and make it a palindrome, it just kind of breaks down. It hits an infinite loop. And so what I actually don't need to do is add these characters to the beginning. Really what I need to do is determine at what point cutting it off turns it into a palindrome. So what I'm going to do is just slowly take one character away from the end of the palindrome string. Basically, that kind of represents what I would have had to do, but I don't actually have to figure out the proper order that they have to come in. So I'm going to do this, and then let's see. All right, well, I've got an infinite loop, so I need to do this and let's see. Okay, just want to make sure that it wasn't replit. Yeah, still doing it. Okay, cool. So one of the things I think that I need to do is make sure that palindrome, the length of it, is greater than 1, right? And this will kind of handle if I pass in like an empty string. So yeah, let's see. There we go. Okay, and then we get to 2. So this kind of gives us a way to stop if we never found a way to make it into a palindrome by like removing characters. So with ABC, we never really we remove C and it's still on a palindrome, and then we remove B, and it is a palindrome at that point, but let's see. Input string never becomes. I was calling it on the wrong thing. That's probably what's going on there. So yeah, let's check. Okay, we're still getting 2. So yeah, so if that makes sense, is palindrome getting called on palindrome as we're removing these characters? It should eventually become a palindrome at this point. Let's try it with this weird input over here. So I'm going to copy this and run this. All right, and we get another 2. So that's good. Now let's just add characters and see if we can make it go up. All right. So it looks like that's working properly. It looks like the number of characters is going up in proportion to the number that we'd have to remove. So it looks like our program is working properly. So I'm going to get rid of these comments now. And then we're just going to kind of go over each line and talk about how much time does it actually take up. Okay. So characters needed, we're just creating that kind of, characters needed 0. palindrome equals input string. So what we're doing here is we're basically doubling the amount of space that it takes. Now, we were given some operations, like directions here, and so we can't really just reuse, or at least I interpret that to mean that we can't really just reuse this thing. But, let's see, well, not, sorry, but, sorry, my neighbors just like came over and like are now talking to people and they're very distracting, I apologize. So anyway, so this doubles the amount of space that we have to use, but not that big of a deal because we're kind of told that we couldn't really do anything other than that. So here, what we do is we loop over the string twice at this point when we call is palindrome. So this is this comparison here is one like iteration through. And then the length of the palindrome function, that's constant. We don't know how many times this while loop is going to run. It may run the number of times that, it may run for once for every character in the string. So like with ABC, we could do, you know, A, B, C, D, E, F, G, you know, and then it just keeps going. Is palindrome would have to run for every single time we mutated this. So because this is linear, this one function here is linear, but because we have to run this function basically one time for every element within the input string, this multiplies n by n. Does that make sense? Okay, so let's see. Just checking to see if any questions relate to this particular thing. Operation should be and any string that cannot be made into a palindrome. There's not really any string that can't be made into a palindrome because if you just kind of add the whole string but backwards, it becomes a palindrome. So no, not really. Okay. We also, we use a like one variable to like increment numbers, but in comparison to input string, it doesn't really do anything. And so we don't really have to express this. So yeah, that's kind of a breakdown of how this works. This is an O of n times n solution. So now that's mostly because, yeah, like I said, it's because of this is palindrome thing. We have to check to see if the palindrome happens for each one. I did look and do quite a bit of research on this problem. There is a algorithm that is better than n to, you know, n times n. It's called the KMP algorithm. It's by Knuth, and it's about if you Google it, the KMP string matching algorithm, it'll get really into the weeds and you can kind of dig into it. And if you're really interested in, this is a little bit like the last one with the bit manipulation, right? Like not every interviewer, and in fact, almost every interviewer will not expect you to get to the bit manipulation solution. They just want to see you interact with a sequence in a rational way. With this one, again, people don't really expect you to like implement the KMP string matching algorithm by, you know, Donald Knuth. That's not really what they're looking for. What they're looking for is that you're able to do something like this. You're able to kind of look over the string and like create like a window and match that string is or isn't a palindrome, and then do an operation. And kind of interact with this comment. That's, you know, that you're only allowed to do this particular operation. It's sort of meant to be like in a more realistic environment. there are some data structures that are so large that like you can only prepend to them or you can only append to them. And or like, you know, that operation is the only one that you can like reasonably do. And so they want to see you be able to interact with super, super large data structures. So this is kind of meant to be that in a small way, basically, if that makes sense. Okay, let's see. Do interviewers expect candidates to have memorized string operations for a given language? Yes. Basically, if you say, yeah, I want to interview in Python, know the string operations in Python. If you know you want to do it in C, know the string operations in C. Just know the built-ins, because what that does is it shows familiarity with the language. Part of the reason why I say, like, you know, the CTO of NPM says all web developers do is split strings all day. It's because like string parsing is one of the biggest like time sucks for any developer, and it's kind of what they spend a lot of time dealing with. Yeah, I mean, that's a lot of times what they think of as judging familiarity with the language. In Python, if you didn't know string or, you know, sequence slicing, and you didn't know, you know, string splitting, for instance, they would kind of go, okay, you haven't used Python before, because everyone kind of expects you to have played with strings in Python. So that's kind of, you know, kind of how this goes. Okay, let's see. Sorry, I had to go over in this one. Any questions on this? Apologize for my distraction. Assaulted by neighbors. I'm going to give you another minute to just look at this, and then hide it, and you'll have to re-figure it out yourselves. All right. Palindrome 0. Yes. So basically what we're doing here is string slicing. It's very much like a list. So palindrome, this is basically saying, give me palindrome, but with one character on the end removed. And that's because I'm addressing the string palindrome from the 0th position, that's here, to the -1th position, that's here. And so if I did that, I'd get these 3 letters. Or, you know, these letters. That's how. Thanks for your question. Anything else? Okay, cool. Well, let's move on to kind of the next one. So last time in the guided topic session, what we did is we looked at, I'm going to make this a little smaller. We looked at tic-tac-toe boards. Can you raise your hand in the chat if you were able to solve at least one portion of this problem? Like you were able to tell me that 1 is the winner of this one or this one, etc. 1 person. Let's see. Oh, here we go. All right, we've got 2 people. All right, all right. That's cool, that's cool. Okay, so if you have not done this one, what we're gonna do is I'm gonna split everybody into breakout rooms. So if you have done this one, I'm gonna put you in another breakout room with the people who've done this one, and we're gonna practice a different problem. But if you haven't, I want you to practice this problem. So yeah, the tic-tac-toe problem is very similar to the valid Sudoku problem. It's kind of like a scaled down version of the valid Sudoku problem. So what we're doing is we have a 2-dimensional array. And 2-dimensional arrays are, they're a difficult problem that you will actually run into a lot of times. This problem is actually really similar to a problem that TripleByte used to use as its like senior developer screening problem. And their problem was literally grade a tic-tac-toe board. Later, they turned it into a Connect 4 board. One of the things that I got to do is read over the like interviewer like guidelines and kind of what are the breakdowns between really advanced people and, you know, kind of newbies. And one of the biggest breakdowns that I want to kind of go over is when you want to loop over a two-dimensional array of any kind. A lot of times people do this. They go for x in, or, you know, they go for y in, you know, this sequence, right? And then for x in this in tic-tac-toe row, right? And for one, this will not work. And two, it's very confusing and you might not realize it's super, super confusing. Don't do it like this. First of all, you know, in Python, this is the element. And so y would be an array here. And so you'd have to put y here. Two, like, this is y, but it's very easy to kind of get mixed up and accidentally put like x first because you think, oh, it's x and y, right? And so you write the x loop first and then you write the y loop, but then you're not really dealing with x and y, and so you have them reversed. This is one of the most common mistakes ever. And it's, you know, it sucks. It sucks to make that mistake. The other thing is when you're dealing with a two-dimensional array, a lot of times you're dealing with relative values. So you want to do something like, here's the middle one, and I want to compare that the middle one is the same as the one next to it and the other one next to it. And in order to do that, we need the actual index of the element, right? And so you want to loop over the range of the length of the list itself. And then you want to do that again. And the thing that you want to change really here is you got to put that variable here, right? But again, x and y, they suck. Don't use x and y. In fact, if you can, don't use single letter variable names. Like most of the time in like a book, a programming, like learn to code book, all the variable names are like single letters. In the real world, like you'll get shot for doing this, okay? Like nobody wants you to use single variable names. They're real bad. So just say, you know, rows and columns. Row and range, column and range, right? Row, right? And then print, you know, and that's tic-tac-toe. Copy it rather than fat finger it. Of row of column. If you do that, you'll get, you know, this, then this, then this, then this, then this, then this, right? 1, 1, 0, 2, 0, 2, 0, 2. 1, 1, 0, 2, 0, 2, 0, 2. It's much easier to reason about it if you put the word row here instead of y, and you put the word column here instead of x. Seriously, I've just seen a lot of like senior devs make this mistake. And it's so easy to swap them, right? So, and then this kind of index is in. So if you want to try to solve this problem, a lot of times what you're going to be dealing with is if statements where, like, you know, you want to check like the middle value. And since you know it's a tic-tac-toe board, you know that tic-tac-toe boards are not, you know, 36 by 36, right? You know that they are 3 by 3. That's how tic-tac-toe works. So you don't maybe even necessarily need to loop over the board because you kind of have a limited number of values anyway. So if you know the size of the grid and the grid's always going to be the same, you don't have to like treat it arbitrarily like with loops. So these are just pro tips. They will come up really soon in interviews and things like that. Any questions on this one? Since so few people have actually finished this problem as in a group, uh, I'm gonna basically manually introduce the next problem to the people who've done this problem. Okay, so let me explain how this will work. I'm gonna split you all into breakout rooms, which will basically be like this call, only smaller number of people. I'm gonna put you into groups of 3. I want you to actually sit down with this problem. I'm gonna link it out in the Slack here. So if you haven't seen it, go ahead and click on it. Click fork. There's a little button here called multiplayer. So once you fork it and you click multiplayer, if you click start session, basically everybody else in this call could, if they join this session, see me typing. And they can also click in it as well. So if you pull up a multiplayer session of your own forked version of this, I want all 3 people to work on it. The idea is you're gonna have to break this down into smaller problems. I've kind of tried to give you that as a hint here. There's 3 cases: the row, the column, and the diag. So what I want you to do is break the problem down into smaller problems, try implementing one, and then adapt the first solution to the next, and then determine what the adaptations are for the third. Walk through the umpire process together. And I want you to basically, once you have one solution that is at least like pseudo-coded out, go to the next person and let them kind of take over and start talking it out. The goal of this is to practice with this problem, but it is also to practice talking things out in front of other people. It's hard. It's harder than you think it is. And if you haven't done the interview yet, or if you haven't tried this yet, you'll be surprised at how your brain kind of freezes up when you have to talk in front of other people, or you just kind of stare at it and you want to just let it happen. But you can't. Don't fall silent the whole time. You got to keep talking, right? Because other people are trying to follow your thought process. So what you're practicing is bringing people along with you with your thought process, because that's what you got to do with the interviewers. Show them that you have a good and rational thought process. Okay, so that's what we're going to practice with this. Okay, so I'm going to kind of put everybody into breakout sessions now, and then I'll jump in with the other 2 people, Jason and I think it was Denise have done these. So yeah. Where's the button? Here it is. Okay. Okay. Cool. All right, I'm gonna open rooms. You're gonna pop into rooms of 3, and I'm gonna come around and make sure you're doing it. Okay. See you soon. Okay.